Okay, number 55. You're at a parade looking up at a large balloon floating directly above the street. You are 60 feet from a point on the street directly beneath the balloon. To see the top of the balloon, you look up at an angle of 53 degrees. To see the bottom of the balloon, you look up at an angle of 29 degrees. Estimate the height of the balloon to the nearest foot. Okay. So, let's just redraw that here. Here's 60 feet. And then here's the top of the balloon and the bottom of the balloon. All right, so basically we want to find the length. None of these are labeled. I'm going to label them though. A, B, C, and D. So we're going to find the length of BD using one measurement, and then the length of DC using another, and then we're going to subtract. BD minus DC will give us what's left over, BD, which is the height of the balloon. All right, so if this is 29 degrees and this is 53 degrees, all right, I guess I'll start with the whole thing first. H is the height of the balloon. The whole thing first, so I'm using the big outer triangle. And well, maybe I'll just redraw that. So we have less things going on. So this is 53, this is 60, and I'll just mark this as X because this is what we're looking for right now. All right, so in the other problems we were, we were just writing ratios. So here we're trying to find the side length. So we have to think about which trig function we're going to use. So, ka, or toa, sine, cosine, or tangent. Well, we have to use the side that we're given and the side that we're looking for. So if we're coming from this angle, 53 degrees, 60 would be the adjacent and X would be the opposite. So we're using opposite and adjacent, which is going to be tangent. That's how you decide which trig function you're going to use. So we're going to set this up. Tan 53, it's always sine, cosine, tangent of the angle equals the ratio, opposite over adjacent. In this case, X over 60. All right, so we have it set up. So hopefully that makes sense to you. If it doesn't, please let me know. Again, we're going to use the side that we're given and the side that we're looking for, which in this case is adjacent and opposite, which tells us we need tangent. Tangent of the angle equals the ratio, opposite over adjacent. Next step is to solve for X. So if we want to isolate X, we need to cancel out that 60 by multiplying it on both sides. So now I'm just going to flip this equation around. X equals 60 times tangent of 53. And then you actually just put that in the calculator. 60 times tangent 53. 79.6227. I'll go to 4 decimal places because that's what the other problems asked for. So that was the whole thing. That was BC, the way I labeled it. Oops. 79.6227. All right, now we need to find DC. Wait a minute. Oh, yeah, we can do that. Okay. So now we're going to use the smaller triangle, ADC. So now it's 29 degrees. This is, I'll just call it X again, and this is still 60. So now we're going to try to find DC. It looks like we're going to use tangent again because we have to go with what we are given and what we're looking for, adjacent and opposite. So this time we're doing tan 29, tan of the angle equals the ratio, opposite over adjacent. x over 60. Next steps, solve for x or isolate x. Multiply by 60 on both sides. So we get x equals 60 times tangent 29. $33.2585. And that is DC, what I'm calling DC. Okay, so if I know the whole thing is 79 something, this part of it is 33 something, then I subtract to get what is left over, which would be the height of that balloon. 79.6227 minus 33.2585. So it's about 46.3642 feet. Oh, it says to the nearest foot, so we'll say 46 feet.